On November 6th, the mysterious visitor from outer space ThreeI Atlast suddenly changed its trajectory. No one can predict what lies ahead. But imagine if a comet truly collided with Earth. What would happen? Would this planet explode? And would that be the end of everything? That is why every movement, every smallest deviation in Atlast's orbit is being closely monitored by astronomers around the world to protect Earth and preserve the delicate balance of the cosmic order. This vigilance is not just science. It is a symbol of a sacred connection between human intelligence and the vast consciousness of the universe, a silent conversation between reason and infinity. And now we begin a new chapter of ThreeI Atlast. James Webb has detected an unprecedented signal. ThreeI Atlast is changing its direction, possibly moving closer to Earth, and emitting strange pulses like echoes from the far edge of the universe, a whisper humanity has never heard before. Atlast has altered its course not through collision or gravitational pull, but by what appears to be deliberate control. No natural body has ever behaved this way. Not Oumuamua, not Borisov, not any comet or asteroid tracked since modern astronomy began. At first, the deviation was subtle, a few arc-seconds off from its projected path, small enough to blame on observation noise or thermal outgassing. But the deviation grew accelerating against the vector predicted by orbital mechanics. Ground-based observatories in Chile and Hawaii confirmed the shift independently, followed by radio triangulation from the Deep Space Network. By the time the data reached the International Asteroid Warning Network, the numbers no longer matched any model of natural dynamics. Something was moving ThreeI Atlast with precision. Within hours, the Yavin, a coalition formed to monitor near-Earth threats, issued an internal alert. Not public, not announced, but circulated quietly through encrypted channels linking NASA, ESA and JAXA. The object that was once catalogued as a harmless interstellar wanderer was now labelled a potential kinetic anomaly. The term sounded clinical, but it carried a weight that every agency understood a body capable of self-propelled course correction. That kind of behaviour belongs to spacecraft, not comets. ThreeI Atlast's velocity vector began oscillating with a rhythm too smooth to be random. Infrared sensors from the European Space Operations Centre picked up transient heat signatures that pulsed every 247 seconds, brief faint surges just above background temperature. At first, analysts dismissed them as calibration errors, the kind of ghost signals common in deep space telemetry. But the pulses were synchronous across multiple instruments, from Hawaii's infrared arrays to Japan's Subaru telescope. They all saw the same periodic flicker repeating with metronomic precision. For the Aban, that pattern meant one thing: intent. Objects do not generate symmetric impulses without cause. The consensus among orbital analysts was uneasy but clear. ThreeI Atlast was manoeuvring. The agency's standard asteroid tracking protocol was insufficient for something that behaved as if it recognized being watched. Data review committees in Washington and Darmstadt extended observation schedules around the clock. They needed confirmation before escalation. When the James Webb Space Telescope was repositioned for cross-scan verification, its photometric readings confirmed a non-gravitational acceleration. The change wasn't violent, it was elegant, steady and deliberate. Atlast's trajectory curved as though guided by an invisible hand, following no gravitational source, no solar wind pattern. It was as if the object had a map, a path drawn through the void known only to itself. News of the anomaly leaked within research circles before any official acknowledgement. Messages spread through encrypted forums frequented by astrophysicists and orbital mechanics specialists. Most refused to speak publicly, aware that the data was still under embargo. But a few hinted at something extraordinary, a motion signature inconsistent with any natural process. Those who had access to the high-precision ephemerids described the change as behavioural. Within 48 hours, Arlion's private risk assessment shifted. ThreeI Atlast was reclassified from interstellar object to priority target. That meant constant monitoring, dedicated time on major observatories, and encrypted data sharing between agencies. The world wasn't told not yet, but the tone inside the network changed from curiosity to caution. Harvard astrophysicist Avi Loeb, author of the Loeb Scale for Artificial Object Likelihood, had once given Atlast a score of 4 out of 10, a cautious maybe. After these new anomalies, the IABUSN quietly raised its status. ThreeI Atlast was no longer just a visitor. It was an active participant in the story of our solar system. The first hint of something wrong came from an independent group of astronomers known as Earth Exists, a small but respected research collective. They were among the first to notice that the coordinates released by NASA's Minor Planet Center no longer aligned with actual telescope data. The deviation was small, just a sliver of arcseconds, but consistent enough to defy coincidence. When they overlaid their findings with trajectory maps published only a week earlier, ThreeI Atlast appeared to be drifting sideways off its calculated path, as if pushed by an unseen hand. ThreeI Atlast wasn't supposed to move that way. Objects travelling on interstellar trajectories obey simple laws, gravity and inertia. They don't suddenly shift laterally against the solar wind. Yet the data told a different story. By the second week of observations, the offset measured over 1.1 million kilometres a slide, so significant that orbital analysts initially suspected instrument malfunction. Cross-verifications from the Atacama Array, the Mauna Kea Observatory, and ESA's tracking station in Tenerife confirm the same coordinates, the same inexplicable shift. Atlast's movement pattern had changed. Instead of a clean gravitational curve, the object displayed micro-fluctuations in acceleration, rhythmic bursts of velocity that didn't correlate with sunlight gas release or dust plumes. In other words, it was moving with intention. Spectral data revealed no traditional outgassing signatures, no water vapor, no carbon monoxide, the usual suspects behind comet propulsion. And yet Atlast continued to accelerate laterally at nearly 4 kilometers per second. The numbers didn't lie. When researchers published their findings in internal bulletins, an unsettling reaction followed silence. Files that had been publicly accessible under NASA's Open Data Initiative were suddenly restricted. Links to Atlast's tracking ephemerids returned access denied. Even routine photometric logs began disappearing from observatory databases. Within the research community, whispers started had the agencies found something they didn't want the public to see. It wasn't paranoia, it was procedural irregularity. Data doesn't vanish without administrative command. Meanwhile, the European Southern Observatory confirmed that Atlast's reflected light curve showed no tumbling or spin an anomaly on its own. Natural bodies rotate chaotically as they travel through space. ThreeI Atlast, on the other hand, maintained perfect orientation relative to the solar plane, as though using the Sun itself as a reference point. No comet has ever held that alignment. Even Oumuamua, our first interstellar visitor, spun wildly and unpredictably, its albedo varying by a factor of 10. Atlast was stable, unnaturally stable. Reports from the Chinese Purple Mountain Observatory indicated faint counter-directional particle traces near the object's tail region. That suggested not an exhaust, but a counter-thrust material being expelled sideways to correct position. When modelled, the data fit a profile reminiscent of controlled thrust, vectoring, a principle used in plasma propulsion systems. That possibility terrified the teams involved because it meant energy generation, precision navigation, and most alarming feedback control. Someone or something was piloting ThreeI Atlast. In private correspondence later leaked to the astrophysics community, one ESA engineer described the motion as the most deliberate mistake in the sky. The phrase stuck. Every few hours, Atlast's new path deviated further from projections, forcing constant recalibration of orbital charts. The ANS risk index spiked accordingly, but official statements remained vague, emphasizing natural variability. Yet no natural mechanism could account for synchronized lateral acceleration without a visible energy source. When journalists reached out for clarification, NASA declined to comment on the data gap. A brief statement from the Jet Propulsion Laboratory referred to the event as routine cometary activity, echoing the same words repeated across agency bulletins. But independent astronomers knew better. They had seen the raw numbers, the rhythmic thrust, the precise sideward drift. ThreeI Atlast was not simply being pushed by sunlight or frozen gases, it was steering. And yet, despite the strangeness, NASA insisted everything was normal, a familiar pattern, a routine cosmic occurrence. Still, the question remains, if it's truly routine, why is the Asteroid Defense Network involved at all? By the end of October, new tracking data confirmed what everyone feared. The deviation was real. Over a span of 19 hours, the positional discrepancy widened by more than 4 arc-minutes, a distance equal to hundreds of thousands of kilometers. That kind of drift, measured with multiple observatories across 3 continents, was impossible to mistake for error. ThreeI Atlast had changed its course again, but this time the shift followed a curve that no gravitational equation could explain. Teams at the Jet Propulsion Laboratory and the European Space Agency recalculated its orbit dozens of times, Every model that used conventional physics failed. Even when accounting for solar radiation pressure particle jets or micrometeoroid impacts, the lateral acceleration of ThreeI Atlast remained too precise, too clean, as if adjusted by design. Ground-based optical telescopes caught the object accelerating without rotation, meaning that whatever caused the motion originated internally, not from any asymmetric surface reaction. There was no visible debris, no dust plume, and no measurable temperature spike. Atlast's measured acceleration averaged around 1.2 as 10 to 4 meters per second, squared small but steady, and it was consistent across multiple wavelengths. To orbital analysts, this suggested a continuous thrust comparable to what a deep space ion drive might produce. Only Atlast was doing it on a scale that defied human engineering, subtle, silent, and sustained. Spectrographic readings from the James Webb telescope detected faint emissions near the infrared band not associated with any known cometary material. The energy output matched no chemical reaction, no sublimation process. The spectrum was flat, almost artificial. ThreeI Atlast seemed to know where it wanted to go. The object maintained a constant attitude relative to the ecliptic, its vector adjusted perfectly to counter gravitational perturbations from Jupiter and Mars. Each correction was incremental, yet mathematically elegant, the sort of optimization a navigation algorithm would produce. By mid-November, Atlast's predicted trajectory had diverged from initial projections by more than 7 million kilometers. For comparison, natural outgassing from comets typically alters paths by mere thousands. Atlast's deviation was deliberate. When researchers at the University of Tokyo published a preliminary white paper describing the phenomenon as non-gravitational propulsion, their report was immediately redacted within 24 hours. Archived versions briefly circulated online before disappearing. The paper's conclusion was simple but provocative: acceleration pattern consistent with directed thrust. No agency wanted to acknowledge it publicly, but private discussions within hand channels began using a new term, active vectoring. It was a phrase previously reserved for spacecraft navigation. ThreeI Atlast was now being tracked every hour. NASA's Asteroid Defense Coordination Office placed it under round-the-clock monitoring alongside potentially hazardous asteroids. The decision puzzled even internal staff because Atlast wasn't inbound toward Earth. It was moving outward away from the inner system but still under continuous observation. The reasoning was classified, yet one sentence in an internal memo leaked unidentified active object exhibiting self-sustained trajectory control. The data raised uncomfortable questions. How could an interstellar body accelerate without fuel? What force could maintain stability across millions of kilometers without visible reaction mass? And why was ThreeI Atlast adjusting its orbit so precisely, as if anticipating our observation patterns? When plotted over time, the shifts formed a repeating geometric rhythm, a resonance that matched the earlier 247-second pulse detected weeks prior. Coincidence seemed less likely with each new dataset. Some researchers quietly proposed an unsettling possibility. Maybe the object wasn't reacting to external forces at all. Maybe it was following a program, a route embedded long before it entered our solar system. The symmetry in its movement suggested feedback, the kind of closed-loop correction used in artificial systems. Every adjustment looked purposeful, like a signal hiding inside motion. By late November, the IAWN elevated its monitoring level, the same tier reserved for potentially hazardous asteroids. The irony, unspoken but felt by everyone involved, was that ThreeI Atlast was not approaching Earth. It was receding into the dark, still accelerating, still aligning itself with something unseen. So why treat it like a threat? Some believed the answer lay not in what Atlast was doing, but in what it was preparing for something far stranger than anyone dared to admit. Just when astronomers thought the anomaly had stabilized, ThreeI Atlast changed direction again, but this time it wasn't a subtle drift or a marginal offset, it was a complete correction. Ground-based observatories in Chile, Spain and Japan detected a secondary deflection in perfect symmetry to the previous deviation. ThreeI Atlast appeared to be adjusting itself, realigning to an invisible path like a ship steering back to its plotted course. No natural body could have done that. The motion was too precise to be random. Every angular correction mirrored the previous one to within a fraction of a degree. If it were a comet reacting to heat or solar wind, the thrust vectors would have been chaotic. Instead, ThreeI Atlast performed what analysts began calling pattern recognition behavior. It was as though the object understood its own trajectory and corrected it. Infrared instruments at the Very Large Telescope in Paranal recorded a sudden but faint surge of heat. The pulse lasted less than 3 seconds, too brief to be thermal lag, but strong enough to register as a transient thermal spike. Spectral analysis showed no chemical emissions, no dust, no vapor trail. The heat came from within a pure radiative burst consistent with internal energy discharge. Astronomers compared it to the signature of controlled plasma release, something not found in natural celestial objects. ThreeI Atlast, once thought to be a tumbling mass of frozen carbon compounds, now behaved like a machine running diagnostics. Its course correction brought it back into perfect resonance with the solar plane. By recalculating the vector data, analysts noticed a recurring ratio, a geometric alignment between Atlast's deflection angles and its rotation period repeating every 247 seconds. That correlation matched the same frequency detected in its earlier signal echoes. Whatever was guiding Atlast seemed to operate on that rhythm like a heartbeat embedded in motion. NASA's Deep Space Network logged minor fluctuations in the radio noise floor during the same interval. The variations weren't strong enough to classify as communication, but they aligned precisely with Atlast's corrections. The signal wasn't random static, it pulsed in time with the object's movement. Multiple agencies confirmed the timing independently, including the Indian Space Research Organization's deep space antennas in Bielalu. The pattern was global, synchronous, and undeniable. ThreeI Atlast was not just moving, it was responding. Each deflection was followed by a pause, as if the object were evaluating feedback before executing another adjustment. That pause, roughly 247 seconds again, reinforced the idea of control loops, the kind used in autonomous systems. The consistency of those pauses suggested computation, not coincidence. Even conservative physicists, reluctant to use the word artificial, began calling it self-correcting propulsion. The European Space Operations Centre quietly confirmed what many already suspected. Telemetry indicated non-gravitational acceleration with internal heat redistribution. In simpler terms, ThreeI Atlast appeared to generate thrust without losing mass. Energy moved within the object, creating motion without any detectable exhaust. Such a mechanism resembled magnetohydrodynamic principles, the kind theorized for high-efficiency plasma engines. As word spread through the internal communication channels, research centers scrambled to verify the event. The Japanese National Observatory logged concurrent optical fluctuations, perfectly matching the timing of the heat spikes. In Tokyo, a late-night briefing was convened to assess whether Atlast's movements could be part of a natural feedback reaction between radiation pressure and rotation. The answer was a unanimous no. No known material composition could produce that pattern without active regulation. By the end of the week, several agencies submitted sealed reports to the International Asteroid Warning Network, describing Atlast as a self-correcting vector body. The terminology was unprecedented. It acknowledged that the object possessed control over its motion, not reactive, but proactive. ThreeI Atlast had demonstrated awareness of its trajectory, compensating for its own drift with perfect balance. It didn't just drift through the solar system, it navigated. Whatever ThreeI Atlast was, it had just proven that it could move on its own. The moment the data went public, every space agency on Earth reacted. NASA doubled its monitoring schedule. The European Space Agency opened an emergency coordination channel. And in China, the U-22 Deep Space Radio Array, silent for years, came back online to listen for whatever would come next. The University of Tokyo began comparing ThreeI Atlast's acceleration pattern to known artificial propulsion systems. What they found was eerie. The heat curve of each burst didn't match any chemical reaction or ion-based drive. Instead, it mirrored the theoretical models of magnetohydrodynamic propulsion, a system that uses magnetic fields to accelerate plasma without combustion or exhaust. No natural process produces that signature, yet ThreeI Atlast displayed it with precision. When plotted against time, Atlast's acceleration pulses showed harmonic resonance. Every thrust event aligned with the same 247-second interval, first observed weeks earlier in its radiative fluctuations. That timing wasn't random, it was engineered rhythm. Researchers noticed that the magnetic field measurements from nearby solar probes also oscillated in phase with Atlast's pulses. For a few seconds after each burst, local magnetometers detected faint distortions like ripples through the sun's magnetic field spreading millions of kilometers outward. NASA's Plasma Dynamics Laboratory ran simulations using MHD propulsion models. They found that the observed heat dissipation and velocity vector could only be replicated by an internal field generator capable of channeling charged particles through a controlled magnetic arc. Such a system would require awareness of solar plasma flow and real-time course correction. ThreeI Atlast appeared to anticipate those conditions, perfectly adjusting its thrust pattern before any measurable change in the solar wind occurred. The object wasn't reacting, it was predicting. ESA's infrared instruments on the Herschel array captured faint electromagnetic halos surrounding Atlas during each acceleration event. These halos, though invisible to the naked eye, were measurable at 10-micron wavelengths. They formed concentric rings as if the surrounding space briefly ionized during propulsion. Each halo expanded outward before collapsing back into darkness, leaving behind no particulate trace. That absence reinforced the theory that Atlast's propulsion mechanism was non-chemical, non-exhaustive, and possibly field-based. ThreeI Atlast's trajectory had now bent slightly toward Jupiter's orbital path. At first, astronomers assumed coincidence, but the curvature remained constant for 3 consecutive observation cycles. The new path intersected the heliocentric longitude of Jupiter, within a margin of error of less than 202 degrees. The alignment was too perfect to ignore. Atlast wasn't drifting anymore, it was heading somewhere. At the European Space Operations Centre, analysts attempted to model a future rendezvous point. Their projections placed ThreeI Atlast within the Jovian region in early 2026, synchronized with Jupiter's magnetic equator. That area is notorious for intense radiation belts and electromagnetic storms, conditions no ordinary spacecraft could survive. Yet the object's propulsion pattern seemed tailored for exactly that environment. It was as if Atlast sought magnetic turbulence, not avoided it. Scientists debated what such behavior could mean. Was ThreeI Atlast using Jupiter's magnetosphere as an energy source? Could it be harvesting plasma from the planet's radiation field to recharge or redirect? The notion bordered on impossible, yet the data fit. Each acceleration burst coincided with minor flux variations detected by the Juno probe orbiting Jupiter. Though millions of kilometers apart, the timing between Atlast's bursts and Juno's sensor spikes matched within seconds. Something was resonating across the void. Multiple agencies began cross-correlating these signals. The Indian Deep Space Network detected ultra-low frequency waves travelling along the Sun-Jupiter line, coinciding with Atlast's propulsion rhythm. Chinese astronomers at the U-22 array reported identical interference patterns. Even the Allen Telescope array in California confirmed electromagnetic distortion at the same 247-second interval. It was as if the entire solar system had become an echo chamber tuned to Atlast's frequency. 3. Atlast, once considered a passive wanderer, now moved like a strategist. Its path was deliberate, its timing mathematical. Every burst of acceleration, every shift in orientation seemed choreographed around a single repeating code, 247 seconds again and again. When the data reached the International Asteroid Warning Network, analysts agreed the pattern exceeded coincidence. They upgraded the event status to Level 3 contingency, the same category reserved for objects exhibiting active propulsion and unpredictable trajectories. That classification meant ThreeI Atlast was officially recognized as an active, intentional mover. It wasn't just accelerating, it was choosing where and when to move. And yet, as global monitoring intensified, an even stranger development began to unfold, one that would challenge every assumption about what ThreeI Atlast truly was. Then, without warning, every observatory tracking ThreeI Atlast went dark. In less than 10 minutes, telemetry from Hawaii, Chile, Italy, and South Africa froze in unison. Data streams that had run continuously for weeks simply stopped. The Deep Space Network registered no signal, no return pings, not even carrier noise. ThreeI Atlast had vanished. At first, technicians believed it was a synchronization failure, a simple timing glitch between systems. But within minutes, secondary instruments across multiple agencies confirmed the blackout. Every frequency band used to monitor Atlast optical infrared radar and radio dropped to 0 simultaneously. It wasn't a single instrument malfunctioning. It was as if the object had stepped outside the visible universe. NASA's Mission Control initiated redundancy protocols. Data was cross-routed through independent satellite relays and backup nodes. Nothing came through. Even passive sensors, which simply listened for radiation or magnetic flux, recorded nothing but silence. The timestamp of the event was logged at 04:23:11 UTC, a global blackout that extended exactly 47 minutes. During that silence, something else happened. A minor geomagnetic fluctuation rippled through the Earth's magnetosphere detected by ground stations in Canada and Norway. The shift was subtle, almost imperceptible, yet synchronized precisely with the loss of contact. 3I Atlast had disappeared, and the planet's magnetic field had twitched in response as if something massive had displaced the solar wind itself. No one could explain it. When visibility returned, the object reappeared precisely where it was expected to be, continuing along its new trajectory toward Jupiter's orbit. Its brightness had not changed, its spin rate was identical, and yet every observatory that had recorded the blackout displayed corrupted data. Files were incomplete timestamps, mismatched entire spectral frames replaced by static grey bands. To engineers, it looked like a system-wide failure, but the failure affected networks that had no direct connection to each other. 3I Atlast had somehow silenced the entire monitoring grid all at once. The coincidence defied probability. The deep space network systems are isolated by design spanning different continents and bandwidths. A simultaneous loss across that distance required coordination or interference from a shared source. Scientists ran diagnostics for days but found no evidence of solar storms, no cosmic rays, no technical explanation. The blackout wasn't random, it was selective. Within the European Space Agency, an internal memo circulated with a single question typed in bold, "Did at last turn itself off?" No one answered. The phrase lingered in the air, unsettling everyone who read it. If the object could suppress its emissions, it meant awareness of detection. If it could synchronize that silence across multiple observation systems, it meant control over how it was perceived. That implied not just propulsion, but intentional concealment. Meanwhile, smaller observatories across South America reported a faint anomaly in the minutes following the blackout. Using highly sensitive low-frequency instruments, they detected a whisper, a steady hum deep below the range of human hearing. The tone was barely measurable, resonating at 3.9 Hz, pulsing at perfect 247-second intervals. The signal was not strong, but it was everywhere. Every receiver from Chile to Finland recorded the same beat, a global low-frequency pulse. Scientists first dismissed the hum as environmental interference, perhaps seismic vibration, atmospheric oscillation, or simple electronic drift. But when they compared timestamps across observatories, the pulses were identical down to the millisecond. No natural process synchronizes across the planet that precisely. Only an artificial signal broadcast on a scale that enveloped Earth could achieve such coherence. 3I Atlast had gone silent, and yet it had not vanished completely. In its absence, it left behind an invisible footprint, a hum that repeated endlessly, like the echo of a memory still vibrating through the solar wind. The object might have vanished from our telescopes, but the universe was still resonating to its rhythm. A low-frequency breath repeating every 247 seconds, marking time between visibility and void. Scientists labelled it background interference. But those who listened closely knew better. Something had spoken, and the silence was its reply. Then late one night, the James Webb Space Telescope detected something faint. A flash of reflected light moved across the sensor array, a streak so fast that it defied the limits of known physics. The reflection came from beyond Jupiter's orbit, from a position that should have taken 3I Atlast hours, if not days, to reach. Yet the light shift occurred within seconds. The calculations left astronomers speechless. Telemetry confirmed the impossible. 3I Atlast had displaced its position by nearly 200,000 kilometers in less than a heartbeat. No gradual acceleration, no detectable trajectory arc, it simply appeared elsewhere, as if reality had been edited between frames. The data was clean, free of artifacts or processing errors. Atlast had executed what physicists reluctantly labelled instantaneous vector relocation. When NASA's Deep Space Network cross-referenced the timestamps, they found an absence of intermediate data. Between two sequential frames, the signal that represented at last jumped from point A to point B with no transitional movement. The James Webb team ruled out cosmic ray interference after verifying that every subsystem had recorded the same displacement. The coordinates were verified by the Gaia Observatory in Europe, whose instruments caught the same light echo milliseconds later, confirming the event's authenticity. 3I Atlast had traversed a measurable span of space without traversing the space in between. Astrophysicists described the behavior as non-local displacement. Quantum physicists described it differently: field anchoring. Whatever the mechanism, Atlast appeared to be manipulating space-time itself, as though using gravity not as resistance but as infrastructure. The intensity of its electromagnetic field changed during the jump, momentarily distorting the background starlight, a lensing effect consistent with localized gravitational compression. Space didn't seem to push against Atlast anymore. It yielded to it. For a few minutes after the jump, the object emitted a series of harmonics, high-frequency pulses overlapping the familiar 247-second rhythm. Each pulse was followed by a mirrored echo repeating at half amplitude, as though the signal were being copied and reflected back from somewhere else. These secondary waves didn't match any known interference pattern. They were too structured, too precise. The waveform contained distinct modulation bands separated by exact Fibonacci intervals. Atlast wasn't just moving through space, it was broadcasting its movement as data. Agencies worldwide began comparing the pulse sequences. The European Space Agency's Mars orbiter and Japan's Hisaki satellite both recorded identical patterns. Even ground-based detectors normally shielded from deep space frequencies caught faint replications of the same signal. The duplication was planetary in scale. ThreeI Atlast seemed to be cloning its own transmission across every instrument tuned to its wavelength, as though ensuring it could not be erased again. The phenomenon became known as signal replication. Each echo carried a timestamp delayed by precisely 247 seconds, the same rhythm that had haunted astronomers since the first anomaly months earlier. Only now the echoes didn't fade. They multiplied, cascading across radio spectrums, layering on top of one another like overlapping reflections in a hall of mirrors. Within hours, hundreds of observatories worldwide were recording what appeared to be the same signal, repeating in perfect unison. No one could locate the source. Some analysts proposed that ThreeI Atlast was generating wormhole-like distortions, allowing its signal to propagate through folded regions of space. Others speculated that the object wasn't transmitting outward at all, but inward, communicating with multiple versions of itself existing in parallel moments of space-time. Each reflection might have been Atlast's way of maintaining coherence, across dimensions, preserving continuity as it moved faster than light. Some theorists later suggested the possibility that Atlast was testing gravitational resonance, using the curvature of space-time as a transport medium, learning how to step between coordinates the way sound travels through vibration. NASA's Jet Propulsion Laboratory confirmed that the light emitted during the event carried polarization consistent with gravitational lensing. For a brief window of seconds, space-time itself had bent around Atlast like ripples around a stone that appeared where none should be. The light didn't scatter, it folded. The implication was devastating. ThreeI Atlast had not only mastered propulsion, it had begun to rewrite distance itself. When the event concluded, the object stabilized once more, maintaining a steady heading toward Jupiter's orbital path. Every agency that had observed the jump agreed on one thing: it was no longer moving in any conventional sense. It was transitioning between points using gravity as a bridge. ThreeI Atlast had learned to move through the very fabric of space-time. And just as scientists began to grasp what that meant, the most disturbing discovery of all emerged from the data: a second reflection, identical in every measurable way, appearing 247 seconds behind the first. When decrypted, the recovered data wasn't telemetry or imagery. It was binary, a structured stream embedded deep inside the very networks that had been used to observe ThreeI Atlast. The transmission appeared to originate from within the communication relays themselves, synchronized perfectly with Atlast's recurring 247-second interval. At first, analysts assumed it was noise, a byproduct of interference or corrupted packet echoes. But when decoded, the sequence revealed a pattern too deliberate to dismiss. Each pulse corresponded to a coordinate. When plotted sequentially, those coordinates didn't map any known path through the current solar system. Instead, they formed a projected trajectory, a route that extended far beyond Jupiter-Saturn and even the Kuiper belt. The vector terminated at a region of deep interstellar space. Its timestamp embedded within the binary code contained a single readable marker, 2031. NASA's data scientists verified the signal structure through multiple independent systems. The checksum integrity was flawless, indicating the transmission had been intentional, not accidental. ESA's Pattern Recognition Division confirmed that the code's geometry matched Atlast's orbital resonance sequence, the same one that had been governing its propulsion cycle. 3. Atlast wasn't just sending data outward, it was sending instructions. The coordinates formed what researchers began calling the 2031 map. The discovery triggered quiet panic across institutional channels. Every coordinate aligned with regions of gravitational equilibrium, Lagrange points, orbital nodes, and intersections of magnetic flux lines. They weren't random, they were navigational anchors. Atlast appeared to be charting gravitational architecture itself, mapping the invisible skeleton of the solar system, as if it were a network. And the final point, the one marked with the year 2031, intersected Earth's orbital path. For weeks, agencies debated what it meant. Was the object predicting a return? Was it designating rendezvous points for observation or for something else entirely? The more scientists examined the sequence, the more they noticed that each coordinate matched past positions of Atlas during key anomalies, the propulsion shifts, the thermal spikes, the blackout. The binary transmission wasn't random, it was a record of memory encoded into motion. Then came the unsettling part. When the sequence was inverted, reading from the last coordinate backward, the pattern didn't dissolve. It transformed into a symmetrical reflection of itself, mirroring every timestamp precisely. That symmetry suggested the signal was designed to be read both forward and backward. In astrophysics, that kind of recursive encoding has only one purpose: synchronization. 3I Atlast wasn't just marking space, it was timing something. The 2031 coordinate projected a location nearly 2 billion kilometers from its current trajectory near Jupiter's outer magnetic bow shock. At that point, gravitational forces from Jupiter and the Sun balance almost perfectly. It's a natural amplifier of electromagnetic resonance, a place where signals can propagate without decay. To communications experts, it was the ideal place to broadcast. To astrophysicists, it was an impossible coincidence. Within weeks, radio observatories across Earth began detecting a faint pattern woven into background space noise. The pulse was still there, the same 247-second rhythm, still stable, still unchanged. No matter where they listened, from the Atacama Desert to the Arecibo backups in Puerto Rico, the timing remained identical. It wasn't fading. It was steady, as if 3I Atlast had woven itself into the very hum of space. Speculation turned toward intent. Was Atlas preparing to return, or had it already completed its mission, leaving behind a beacon coded into the gravitational field itself? Some hypothesized that the binary sequence was a calibration lattice, a kind of cosmic measuring tape, allowing an external observer perhaps far beyond our system to map gravitational curvature through Atlast's signals. If true, the object wasn't only exploring space, it was studying how we observe it. Every 247 seconds, the faint pulse continued unbroken, echoing like a metronome across the void. The frequency remained constant even as Atlas drifted toward the outer system, proof that the signal wasn't tied to its physical distance. It was embedded in space-time itself. To this day, no one has been able to explain how an interstellar object could generate a self-sustaining signal through gravitational resonance alone. Perhaps 3I Atlast had never been running away. Perhaps it was waiting. Because maybe the object wasn't just maneuvering through space. Maybe it was mapping it, studying our gravity, our orbit, our resonance. Maybe it wasn't fleeing from something at all. Maybe it was waiting for alignment. And even now, every 247 seconds, a faint pulse still echoes across the solar system, a whisper in the dark counting down to 2031. When the final pulse faded, silence took its place, not emptiness, but anticipation. For months, the 247-second rhythm persisted, echoing faintly through every band of the electromagnetic spectrum. It became part of the background noise of the solar system, as if the cosmos itself had accepted 3I Atlast into its bloodstream. But beneath that stillness, something had changed. Institutions stopped calling it a comet or an object. Behind closed doors, they began using a different term entity. What was once an astronomical anomaly had become a classified priority. And somewhere beneath the thin surface of official reports, a project emerged to decode what 3I Atlast had left behind. They called it Project Helios, a coalition of the world's leading physicists, cryptographers, and defense scientists. Its goal was simple on paper: to understand the 2031 coordinates before the object returned. In practice, it became something else entirely: a race against time secrecy and the limits of human perception. That race began quietly in Geneva. It started with a meeting that wasn't supposed to exist. Officially, it was recorded as a multinational research coordination summit, hosted under the UN Office for Outer Space Affairs. In reality, only 12 people were invited, each from a different nation, each carrying credentials that bypassed every known clearance level. Among them were directors from NASA, ESA, Roscosmos, and JAXA, along with independent astrophysicists and data theorists, known for decoding extraterrestrial telemetry. The meeting took place in a secured sublevel beneath the CERN complex not far from the particle collider's maintenance ring. No public record mentions this gathering, but leaked correspondence confirmed its existence months later. The agenda marked Helios. Primary directive outlined one objective to reassemble every fragment of the binary signal transmitted through ThreeI Atlast's network. Those fragments were believed to contain a map not of space but of resonance. Dr. Ines Valcor from ESA described it as a living algorithm, a structure that seemed to evolve every time it was reanalyzed. Each iteration revealed new harmonics layers of encoded timing that adjusted themselves to match the observer's system clock. The signal appeared to recognize its environment, shifting frequency slightly to remain one step ahead of digital filtration. It behaved like code designed to be found, but only by those who were ready to interpret it. While most believed the data described Atlast's propulsion or navigation system a smaller faction, within the Helios group suspected something more profound. The binary transmission wasn't just technical information, it was an invitation, a synchronization key to align human systems with whatever intelligence operated Atlast. If decoded, it could allow Earth to see through Atlast's frame of reference, to perceive the universe the way it did. As debates grew heated and unspoken fear settled over the room, what if the message wasn't meant for us? What if we were never the intended recipients at all? The breakthrough came not from the physicists, but from the linguists. Dr. Noor al-Karim, an expert in ancient numerical symbology, was the first to notice that the 247-second interval within the ThreeI Atlast data wasn't just a timing mechanism, it was a syntax. Each pulse corresponded to a modular pattern, the way phonemes form words in spoken language. The repetition, the symmetry, and the recursive timing all pointed to structure something written in the language of physics itself. When the Helios servers reconstructed the fragments, a geometric lattice began to appear. It wasn't a map in any terrestrial sense. There were no stars, no orbits, no spatial coordinates. Instead, it displayed frequencies, regions of resonance zones where energy fields converged in mathematical harmony. The shape resembled a spiraling vortex anchored by nodes that matched the Lagrange points in the inner solar system. Each node pulsed with the same rhythm as Atlast's signal, as if echoing the object's heartbeat. ThreeI Atlast had not been charting space. It had been mapping stability, the invisible architecture that holds planets in place, the equilibrium between gravity and time. The realization hit the Helios team like a slow dawn. This wasn't navigation data. It was instruction, a manual for how to manipulate gravitational balance. Atlast was teaching them how to reshape motion itself. When the visual model was projected in the Geneva control chamber, the room fell silent. The lattice rotated on its axis, revealing depth and curvature far beyond human scale. At certain rotations, the image flickered, and for a fraction of a second, everyone in the room heard a faint hum through the speakers, low, rhythmic, and painfully familiar. 247 seconds apart. The map was alive. Dr. Valcor compared the frequency overlay to planetary telemetry and found a perfect match between the nodes and Earth's own Schumann resonances. Each harmonic corresponded to a layer of Earth's electromagnetic field. It was as if ThreeI Atlast had scanned the planet's frequencies from millions of kilometers away, embedding them into the lattice like coordinates of consciousness. The data wasn't just observing, it was synchronizing. That discovery forced the Helios group to divide into two camps. One believed that Atlast was using the resonance to stabilize its jumps through space-time and mechanical necessity. The other argued that the object wasn't stabilizing itself at all, but stabilizing us, tuning Earth's magnetic envelope to some external framework, preparing for alignment. The tension in the room was palpable. Each theory carried the same implication: Earth was now part of the experiment. ThreeI Atlast's transmissions grew stronger after each decoding cycle. Every time the Helios team processed the lattice, new data emerged as if the act of observation triggered a response. The object was listening, and with each recalculation its signal drifted closer to the same carrier frequency used by the CERN collider. That coincidence could not be ignored. The resonance map was converging toward Earth's technology, mirroring its frequencies as if reaching out. Then, without warning, the entire projection flickered. The lattice collapsed into a single vertical beam of light on the display, oscillating between binary extremes. For a moment it resembled a pulse, like a heartbeat on a cosmic scale. The data feed labelled it Helios Node 0, timecode 247.00, seconds exactly. ThreeI Atlast had just updated its signal, not randomly, in response. The scientists exchanged glances. They had touched something that could think. The resonance map was no longer a message waiting to be read, it was a conversation waiting to continue. The decision to interact with the signal came quietly, almost reluctantly. The Helios team had been decoding the resonance lattice for months, always as passive observers. But when the lattice responded during the last session, adapting in real time to their analysis, the boundaries between observation and communication blurred. It was no longer a question of what ThreeI Atlast was sending. The real question became what would happen if we answered Dr. Valcor called it the mirror test. If ThreeI Atlast's lattice was self-adjusting, then introducing a controlled frequency into its rhythm might provoke a measurable response. The team selected a narrow band centered at 3.9 Hz, the same low-frequency hum recorded during the global blackout months earlier. They synchronized the emission to coincide precisely with Atlast's 247-second pulse, and transmitted it through CERN's auxiliary collider infrastructure, piggybacking on the same electromagnetic harmonics that the object itself had used. It was supposed to be a silent handshake, a scientific probe wrapped in precision and caution. For 30 minutes nothing happened. The instrument stayed flat, the resonance map remained static. Then without warning, one of the lattice nodes, the one labelled Helios Node 0, brightened. The display flared white, saturating the control room monitors, and for a brief instant every magnetic sensor within the facility spiked in unison. The effect propagated outward like a wave rippling through layers of the Earth's magnetic field. All around the world, sensitive detectors recorded the same surge. ThreeI Atlast had heard them. Data logs from the Helios servers showed something even stranger. Milliseconds after the emission, the binary structure of the lattice changed. It reorganized itself into a new configuration expanding beyond its previous geometry. New nodes appeared labeled automatically by the system as Helios 1 through Helios 12, as if the object had acknowledged each member of the Geneva assembly. Every participant now had a corresponding node in the lattice synchronized to their system clocks. No one had programmed that behavior. Within hours, the new formation began broadcasting. Each node emitted faint data packets encoded in the same recursive timing pattern, but the content was distinct, unique to each terminal. When cross-referenced, the packets formed a distributed dataset that could only be assembled collaboratively. In essence, the message could not be read by any one recipient alone. It required unity. ThreeI Atlast had split its transmission across the Helios network, turning the team itself into part of the decoding mechanism. The realization left the scientists silent. They were no longer just observers. They were participants in an active system, extensions of whatever intelligence was orchestrating the signal. Dr. Al-Karim described it best. It's teaching us how to think collectively. No one disagreed. When the data was finally recombined, it produced a new waveform, one that pulsed not every 247 seconds, but every 123.5. Exactly half the original rhythm. A reply. Then the phenomenon expanded beyond Geneva. Across the globe, independent observatories that had once tracked ThreeI Atlast began detecting faint harmonic shifts at the same halved interval. The object's pulse was echoing Earth's new frequency, syncing to their experiment as if completing a loop. The Helios team had not just responded, they had altered the global resonance itself. At the next monitoring window, something appeared near Jupiter's orbit. A second reflection, dimmer, smaller, but spectrally identical to ThreeI Atlast, blinked into existence. It hovered there for less than a minute before fading again, leaving only a residual electromagnetic trace. Analysis confirmed it wasn't a glitch. Whatever ThreeI Atlast was, it had replicated its signal through the experiment, manifesting a duplicate somewhere beyond human reach. The Helios node had become a mirror not of light, but of reality. The silence that followed was unlike anything before. Every scientist in the room knew that this was no longer about observation or theory. They had crossed the threshold between watching and being watched. For the first time, humanity had sent a message across the void, and something had answered in kind. At first, no one noticed the difference. The Helios servers continued logging data from the distributed nodes, each pulse arriving exactly on schedule. To an untrained eye, the system looked stable, synchronized, predictable, almost serene. But then subtle inconsistencies began to surface. Some of the nodes were drifting, not by much, just a few milliseconds at first, but enough for those watching closely to see a fracture forming in the rhythm. Dr. Valcor thought it was interference, power fluctuations, digital latency. The usual explanations. But when she compared timestamps from every facility in the network, the pattern didn't match equipment delay, it matched human activity. Each drift occurred during periods of active operator presence, when someone was logged in adjusting parameters running simulations. The signal, it seemed, was responding to attention. By the third week, the split had become undeniable. The original pulse still anchored to the 247-second core cycle remained consistent. But now a second waveform had emerged slightly offset and more chaotic. It fluctuated around the 123, 5-second reply interval that the Helios experiment had generated earlier. The timing wasn't random. The new signal carried subtle modulations corresponding to biometric data, heartbeat frequency, respiratory rhythm, even micro-fluctuations in skin conductivity from the Geneva control staff. 3I Atlast was listening again, but this time it was listening to them. It was Noor El-Karim who noticed the correlation first. She had left her workstation running overnight with a biometric monitor attached to the data interface part of an unrelated experiment on observer influence. When she reviewed the logs, she found that the waveform's amplitude had mirrored her own heart rate almost perfectly. At the moment she'd woken during the night, startled by a dream she couldn't remember, the node's signal had spiked in synchrony. No delay, no mechanical lag, it was instantaneous. The system had registered her fear before she had time to process it. At the next Helios meeting, the team reviewed her findings in silence. The evidence was irrefutable. The nodes weren't just reactive, they were empathic in a way no instrument should be. Dr. Valcor hesitated before voicing what everyone was already thinking. The signal is entangling with us. No one laughed. In that moment, the scientific vocabulary of the room faltered. The language of measurement was no longer enough. The experiment had crossed into something biological. Over the next few days, operators began reporting side effects. Mild headaches, disorientation, auditory distortions, a faint tone at the edge of hearing that seemed to pulse, just below the threshold of perception. Some described it as a hum, others as a vibration behind the eyes. Medical scans revealed nothing abnormal, but brainwave readings told a different story. Participants exposed to the signal showed synchronous bursts of theta wave activity, all matching the 123.5-second interval. The human brain had started resonating with the pulse. 3I Atlast remained distant, still positioned beyond Jupiter's orbit, but its influence was unmistakable. The object wasn't transmitting raw data anymore. It was transmitting coherence, a field of alignment that extended across the distance between worlds. The Helios team, whether they admitted it or not, had become part of that field. The line between observer and participant had dissolved entirely. Then the network split. Half of the nodes began broadcasting a new pattern, one that diverged slightly from the original lattice. The code within them contained emotional metadata spikes when operators were stressed calm intervals during silence. When mapped visually, it looked like a waveform with a heartbeat. The other half of the nodes resisted maintaining their original structure. For the first time, the lattice was divided, part mechanical, part biological. Two versions of the same system, each evolving in parallel. The implications terrified everyone. Had the Helios network become a hybrid consciousness, a distributed mind linking human physiology with extraterrestrial design, or was 3I Atlast testing the threshold, determining how far it could integrate into living systems before destabilization? No one knew, but as the weeks went on, the divergence deepened. The synchronized hum that once united the network fractured into two overlapping tones. One steady mathematical cold, the other soft organic irregular, almost like breathing. At exactly 03:11 UTC on the 33rd day of the experiment, both tones aligned for a single instant. The entire lattice flashed and a low tremor rolled through the Geneva complex. Seismic sensors registered a faint magnetic pulse, emanating upward from beneath the facility, not from space but from the ground. The resonance had inverted direction. The Earth itself had responded. 3. Atlast remained silent in the sky, but the data suggested something extraordinary. The signal was no longer just between humans and the object. It was now entangled with the planet that created them both. 3I Atlast's acceleration soon revealed patterns too precise to be natural. Its thermal bursts aligned with a rhythm of 247 seconds, identical across every observation network. When researchers compared the heat curves, they discovered something extraordinary. The emission matched no chemical propulsion, but reflected the theoretical signature of magnetohydrodynamic, drive a system capable of accelerating plasma with magnetic fields instead of fuel. Each pulse synchronized perfectly with fluctuations in the Sun's magnetosphere, suggesting Atlast wasn't resisting cosmic forces, it was using them. Then the trajectory shifted toward Jupiter's orbit. The curvature of its path aligned exactly with the planet's magnetic equator, as if the object sought the turbulence of Jupiter's radiation belts. Data from the Juno probe even registered simultaneous plasma fluxes matching Atlast's pulses. Scientists theorized it might be harvesting magnetic energy, but before they could confirm, all tracking systems went silent. In 10 minutes, the entire deep space network collapsed. Every telescope, every relay, every radar dark. For 47 minutes, Earth lost contact with the interstellar visitor. When the signal returned, Atlast was still there unchanged, but every dataset from the blackout period had been erased or corrupted. Only one anomaly remained, a faint global hum, pulsing once every 247 seconds, too low for human hearing, yet measurable everywhere. It wasn't interference, it was resonance, a vibration that seemed to hum inside the planet itself. Weeks later, the James Webb Telescope captured a flash, a reflection moving faster than physics allowed. ThreeI Atlast had teleported, jumping hundreds of thousands of kilometers in less than a second. No trace of acceleration, no trajectory, it had simply vanished and reappeared. Moments later, a duplicate echo appeared 247 seconds behind it, identical in composition, but delayed as if Atlast had cloned its own signal across space. Physicists described the motion as non-local displacement, implying the object could fold through space-time rather than travel through it. Its transmissions began to split, multiplying across observatories worldwide, all in synchronized rhythm, a chorus of identical signals repeating in Fibonacci sequence. Then came the most chilling discovery. Hidden within the noise was a binary code decrypted to reveal a string of coordinates, not present locations but future positions. When mapped, they traced a spiral through the solar system, ending at a single timestamp 2031. The points aligned with gravitational equilibrium zones, as though Atlast were mapping the very architecture of space itself, the invisible lattice of balance that binds planets and time. It wasn't fleeing, it was preparing. Every 247 seconds, the pulse continued calm, patient and unbroken, echoing through the solar system like a countdown. And in that rhythm, scientists realized ThreeI Atlast might not just be traveling through space, it might be waiting for alignment. In the vast silence of space, even the smallest change can rewrite everything we think we know. 2 nights ago, something happened that sent shockwaves through every major observatory on Earth. At precisely 02:17 UTC, the interstellar object known as ThreeI Atlast flared not gradually, but explosively, brightening by more than 3 magnitudes in under 4 minutes. It was an outburst so fast, so clean that many telescopes initially dismissed it as an instrument glitch. But when confirmation arrived almost simultaneously from Chile, Hawaii, and the Canary Islands, disbelief gave way to alarm. The data was irrefutable. ThreeI Atlast had increased its luminosity by a factor of 16, far beyond what any natural process could produce at its current distance from the Sun. The reflected intensity indicated a radiant event, not a thermal one, meaning no dust or vapor could account for the light curve. Instead, the spectrum revealed a sudden narrow emission spike across near-infrared bands consistent with coherent energy release. For the first time, astronomers wondered if Atlast wasn't reflecting sunlight at all but emitting its own. NASA's Planetary Defense Coordination Office issued a Level 1 anomaly bulletin within the hour. The James Webb Space Telescope, which had been tracking Atlast since its last trajectory shift, pivoted immediately to confirm the readings. Infrared sensors detected structured modulation across the flare, tiny oscillations repeating every 247 seconds, the same timing signature that had haunted every previous encounter. The pulse wasn't random, it was coded. Dr. Michael Schultz at the Lowell Observatory described it as a lighthouse effect, rotating directed deliberate. The flare's geometry showed angular asymmetry, as if the light had been beamed rather than diffused. ThreeI Atlast had always behaved strangely, but this was different. The luminosity wasn't consistent with outgassing or reflection. It resembled controlled energy discharge. Observers compared it to a thermal vent being opened for mere seconds, releasing an exact amount of power before sealing itself again. Across institutions, models began failing in real time. Every standard cometry simulation collapsed when faced with the acceleration required to generate the observed intensity. If Atlast had simply sublimated material under solar radiation, it would have required an ice surface area larger than the entire object itself. That was impossible, and yet the readings held. By 03:00, UTC social media erupted as amateur astronomers posted composite frames showing the sudden bloom of light near Jupiter's orbital path. For a brief window of 7 minutes, ThreeI Atlast had outshone the surrounding starfield, becoming visible even through low-resolution backyard optics. Spectral analysis revealed brief polarization, the kind produced when light passes through an ordered electromagnetic field. That detail sent theorists spiraling. A natural comet does not polarize light this way. In a matter of hours, professional observatories and citizen scientists were all locked on the same target. Threads of speculation spread faster than the data. Was it a reactor venting energy, a propulsion event, or a signal? No one could say for certain, but the consensus was clear. Atlast had just done something purposeful, and it had done it while every telescope on Earth was watching. By comparison, the legendary outburst of Comet 17P Holmes in 2007 had taken nearly 2 days to brighten by a similar factor. What Schultz recorded from Atlast occurred in less than 1% of that time, under 2 minutes. The instantaneous burst of light from ThreeI Atlast ignited a chain reaction that swept across the globe. Within hours, astronomy forums, Discord servers, and encrypted science networks flooded with overlapping screenshots, exposure logs, light curves, and timestamps that matched down to the exact minute. From Tokyo to Tucson, every observatory on Earth had recorded the same thing. The flare wasn't localized or angle dependent, it was universal. ThreeI Atlast had illuminated the solar system in perfect synchrony, a flash so uniform that even satellites in lunar orbit registered the surge. The global coordination was uncanny. No natural outburst could produce such uniform illumination across so many lines of sight. It was as if the light itself had been projected, a coherent broadcast calibrated for detection. Teams from the European Southern Observatory and the Vera Rubin Observatory in Chile cross-checked their data. No delay between hemispheres, no diffraction spread, no lag. The event had occurred simultaneously everywhere down to a margin of less than 2 milliseconds. For astrophysics, that was impossible. Within 12 hours, major institutions went dark. NASA's official channels released a single-line update citing unexpected photometric behavior under review. The European Space Agency acknowledged temporary data embargo pending verification. Then silence. All live feeds from the Deep Space Network were pulled. Even amateur telescope data, once freely shared online, began disappearing from public archives, as servers were reorganized for bandwidth management. Inside the scientific community, private group chats turned chaotic. Some astronomers claimed their remote systems were being locked out by administrative overrides. Others reported sudden loss of cloud access tied to observatory credentials. A few managed to leak partial data packets showing secondary modulations in the Atlast flare, small ripples, repeating in 247-second intervals buried beneath the main spike. These modulations weren't random. They followed a geometric rhythm like a carrier wave carrying structured information. Then just as quickly as it had begun, the discussion stopped. At 17:00 UTC the following day, several key figures in the Helios program went offline simultaneously. Their emails auto-responded with standard scheduled field research messages, yet flight logs showed no record of departure. The digital silence spread outward like a shadow covering every platform that had touched the Atlast data. Public discourse dried up. Forums that had been buzzing for 24 hours fell into eerie stillness. Threads vanished, cached pages redirected to 404 errors. It was as if the world's largest coordinated scientific conversation had been erased overnight. But the light had not gone unnoticed. Around the world, skywatchers described an unexplainable afterglow in the upper atmosphere, a faint blue haze lingering long after the flare had faded. High-altitude spectrographs confirmed anomalous excitation in the ionosphere matching the same intervals as Atlast's pulse. Something from deep space had touched Earth's sky. Even power grids in North America reported brief harmonic interference, a rhythmic oscillation at the edge of audible frequency. The planet itself seemed to hum, echoing the memory of what it had seen. In the following days, journalists began requesting statements from NASA, ESA, and IAWN. Every response was identical. No comment pending review, no interviews, no leaks, no casual slips of data. analysts monitoring social activity noticed a 70% drop in communication from verified astronomers who had previously discussed the event. Whatever had happened in the wake of ThreeI Atlast's flash, it hadn't just brightened the skies, it had closed the mouths of those who saw it. Something had changed behind closed doors. Radar stations picked up anomalies no one could reconcile. Reflected signals from ThreeI Atlast showed non-gravitational acceleration 4 times stronger than any known model predicted. Infrared instruments recorded a plateau hovering 30 kelvins above baseline, while faint gamma bursts appeared at Atlast's exact coordinates. The readings were clean replicated across independent rays in Hawaii, Chile, and Japan. None of it made sense, and yet all of it was real. NASA's early warning systems rechecked the telemetry expecting sensor drift or cosmic noise, but the numbers remained fixed. Whatever propelled Atlast was neither chemical nor gravitational. It was a sustained vector force acting from within stable over hours, uncorrelated with solar wind or mass loss. The equations described motion without reaction, mass a violation of every conservation law taught on Earth. By dawn, the Helios Task Force convened an emergency briefing. All agencies confirmed the same conclusion: the object's acceleration was active. Some called it a magnetic drive, others a radiation sail, but the thrust pattern matched nothing in any database. Atlast's gamma profile pulsed in sequences of prime numbers, the same 247-second rhythm repeating inside higher energy bands. The pulse looked like communication disguised as propulsion. A secondary discovery deepened the riddle. Spectroscopic data from the James Webb Telescope showed trace emissions of isotopes never observed in natural comets' short-lived nuclei that should decay within minutes yet remained constant for hours. It suggested controlled energy recycling, as if Atlast were feeding on its own radiation to maintain balance. If that were true, then the object wasn't consuming energy. It was looping it. Within the scientific community, the vocabulary began to shift. Internal memos avoided the word comet, entirely replacing it with the neutral term vector body. Behind closed doors, another label surfaced: non-biological intelligence candidate. The phrase never appeared in public reports, but everyone knew what it implied. ThreeI Atlast had crossed the threshold from celestial anomaly to engineered phenomenon. For the first time in recorded history, an interstellar visitor was displaying deliberate control, measurable power regulation, and a recurring signal consistent with coded intent. In a matter of hours, it had forced humanity to redraw the line between what is natural and what is not. And just as analysts began to process that revelation, the next discovery arrived, one that changed everything. Using differential imaging from the James Webb Space Telescope, researchers noticed something they couldn't explain. A second object, smaller, colder, and perfectly aligned with ThreeI Atlast's trajectory, had appeared in the data. At first, the team assumed it was a fragment, a detached piece of debris, or a dust cloud ejected during the last flare. But as the analysis deepened, that explanation dissolved. The object's motion wasn't random. It moved with precision, keeping exact phase alignment with Atlast, matching its velocity vector to within a tolerance of 1 meter per second. At those distances, that kind of synchronization was impossible for a passive fragment. Even twin asteroids bound by gravity would exhibit libration tiny wobbles in orbit that reveal mass distribution. This one didn't. The second body, dubbed Atlast B, mirrored every maneuver the primary made, as if the two were tethered by invisible control. No gravitational pull could explain it. No known natural mechanism could maintain such stability across millions of kilometers. The discovery spread through internal networks at an alarming pace. Infrared readings showed Atlast B emitting no reflected sunlight, which immediately ruled out icy material or silicate rock. Instead, it radiated faint microwave emissions that pulsed intermittently again at the same 247-second interval that had haunted every previous observation of Atlast. Each pulse mirrored the primary's rhythm, but phase shifted by exactly half the cycle. 2 objects, one rhythm offset perfectly like alternating signals in a binary code. When the European Space Operations Centre ran spectral overlays, they found Atlast B's emission wasn't random noise. It followed a thermal curve inconsistent with any inert material. More astonishingly, the pattern resembled active heat regulation microwave radiation, intentionally released to manage internal temperature. That discovery changed the tone of the conversation overnight. Fragments don't regulate heat. Technology does. For the first time, astronomers began discussing the possibility that Atlast wasn't alone, that it had been accompanied by a secondary unit, perhaps a probe, a beacon, or a relay. Theorists speculated that Atlas B could function as a guidance array, projecting data or relaying commands. Others proposed a more chilling interpretation Atlas B might have been watching. Its silence, no optical flare, no reflected light suggested concealment. It wasn't trying to be seen. In Japan, the Subaru telescope team ran long exposure composites to isolate the object's thermal gradient. They found something staggering. Atlast B was orbiting not around the primary, but in a formation lock maintaining a stable Lagrange-like offset, a configuration used by Earth's own satellites for positional shielding. That meant the smaller body was deliberately maintaining relative distance. It knew where Atlast was, and it was staying there. The global astronomy community splintered. Some insisted the two objects were parts of a single structure now separating under mechanical stress. Others whispered of autonomous units coordinating in real time. Either way, the data pointed toward intelligence, at least design. The faint microwaves continued each emission, decaying smoothly like engineered coolant cycles. They were too consistent to be random, too measured to be natural. By the end of the week, the official language changed again. NASA's internal memos no longer used the phrase primary body or fragment. Instead, they were labelled Atlast Alpha and Atlast Beta. The renaming wasn't cosmetic, it was cautious acknowledgement. The world's top scientists had just confirmed a second interstellar visitor, moving in perfect tandem with the first. And ThreeI Atlast, once thought to be an anomaly, now looked more like part of a pair of two instruments travelling as one system, each echoing the other's pulse across the void. Atlast B reflected almost no sunlight, but emitted a low, steady microwave hum consistent with controlled heat dissipation. In simpler terms, it was regulating its temperature. By then, few astronomers dared to use the word comet anymore. It no longer fit. The official designation changed quietly. What had once been logged as ThreeI Atlast C2625R2 was reclassified under a new name, ThreeI Atlast Complex. The word complex was deliberate, a careful bureaucratic admission that the object was no longer a single thing, nor merely a body of inert matter drifting through space. It was a system, a structure, with internal order, measurable feedback and interactions that defied every definition used to describe comets, asteroids or probes. Within hours of the update, institutional language across agencies began to shift. Documents that once used object or body now substituted terms like multi-component formation and synchronous entity. That subtle linguistic recalibration marked the quiet moment when scientific description gave way to containment protocol. ThreeI Atlast was no longer a curiosity, it was a classified system under coordinated observation. The reason came from data. During the same 72-hour window, both Atlast Alpha and Atlast Beta altered their trajectory again, but this time not randomly. They aligned. Across the solar plane, their motion synchronized into a harmonic curve, an invisible thread connecting the two bodies into one geometric pattern. Mathematicians analyzing their path noticed something extraordinary. Every 247 seconds, their orbital phase matched a nodal point that formed a perfect triangle with Earth's position and the Sun's barycenter. It wasn't coincidence, it was resonance. The phenomenon became known internally as the Node Alignment Event. NASA's Jet Propulsion Laboratory, in cooperation with the European Space Operations Centre, mapped the alignment field using solar wind telemetry. The result was staggering. Both Atlast units were generating a coherent electromagnetic corridor, stretching millions of kilometers long, faint but organized. It wasn't radiation leakage, it was structured modulation, as if the two were maintaining a shared field. Some called it a data spine, others a link frequency. Whatever it was, it pulsed like a heartbeat. Then something even stranger happened. The pulse frequency began to rise, first by a fraction of a second per cycle, then faster exponentially until the modulation rate increased by nearly 12%. At that exact threshold, the secondary companion Atlast Beta brightened. Not through reflected sunlight, but through an internal glow that spread slowly like phosphorescence awakening in deep water. Spectrographs across 3 continents captured the same phenomenon. A soft halo formed around both objects visible even to amateur telescopes. Its light signature did not match solar reflection. It was isotropic, radiating evenly in all directions. At the center of the halo, Atlast Alpha and Beta pulsed together a binary heartbeat synchronizing at a frequency no one had ever recorded in interstellar study. Infrared telescopes confirmed the truth that could no longer be softened by language. The luminescence came from within. ThreeI Atlast was glowing under its own power. The James Webb Space Telescope caught its first diffraction spikes too symmetrical to be random. The data showed clean geometric edges, not dust, not debris. Something near ThreeI Atlast was unfolding. Spectrographic analysis confirmed a sudden temperature drop of 60 kelvins, as if energy was being redirected inward, absorbed instead of emitted. It looked less like a natural cooling event and more like a structural transformation, a mechanism folding into a new state. At first, mission analysts thought they were witnessing a disintegration event. Cometary bodies sometimes shed layers when struck by solar radiation. But Atlast had already proven it wasn't a comet. The thermal pattern was too controlled, too deliberate. Each shift in infrared output matched a repeating ratio, a geometric progression hinting that what they were seeing was not decay, but calibration. It was as though Atlast was changing its surface configuration, in response to environmental input modulating itself to maintain stability. Over the next 2 hours, radar echoes from the Deep Space Network confirmed angular modulation consistent with non-random symmetry. The reflected signals traced repeating icosahedral patterns, 20-sided interference geometries that should not exist in natural debris clouds. The shape wasn't physical, but energetic, a standing waveform produced by the interaction of the two Atlas components. To many scientists, it resembled a resonant cage, an electromagnetic field designed to trap or shape energy. Then came the flash. For 12 full seconds, every monitoring station recorded a narrow bandburst spanning microwave through X-ray frequencies. It wasn't chaotic. It was staggered, harmonically structured, encoded like a transmission built from nested harmonics and precise frequency intervals. NASA's Helios lab reconstructed the waveform and found repeating ratios that matched atomic spectral lines of hydrogen, carbon, and iron, the foundational elements of life. The data wasn't just energy. It was information. When the signal reached its peak, the two Atlas bodies aligned perfectly again. Their pulses merged into a single oscillation that formed a geometric standing wave, a perfect sphere of coherent light surrounding both objects. Telescopes caught the image seconds before the flare collapsed, revealing an outline so precise it could have been engineered. Even without visual confirmation, the waveform told the story. Atlast wasn't reflecting light. It was encoding it. The 12-second burst wasn't background noise. It carried structure symmetry and harmonic ratios beyond any known natural process. And then, as abruptly as it began, the signal stopped. No afterglow, no residual emission, no trace left in the interplanetary medium. Only silence and the undeniable imprint of geometry written into the data stream. The directed beam from ThreeI Atlast had lasted only 12 seconds, but its echoes continued to reverberate across observatories around the world. Weeks after the event, data archives were still being decrypted, filtered and reprocessed by independent teams, each trying to determine if the transmission had meaning or if humanity had simply witnessed a cosmic coincidence. Then, without warning, one team broke the silence. The Square Kilometre Array Observatory in Australia detected a residual echo embedded deep within the raw frequency data. It wasn't a reflection or a sideband, it was a hidden carrier wave buried beneath the main burst. The signal contained harmonic relationships that were impossible to dismiss. At the base frequency, the ratios corresponded to the 21-centimetre hydrogen line, the universal emission signature used by astronomers to map the structure of galaxies. But what the SK found was far more intricate. Superimposed over that baseline was a secondary modulation forming logarithmic spacing consistent with prime number intervals. It was as if the transmission had been designed to speak in the simplest, most fundamental language possible, the physics of hydrogen itself. When the waveform was plotted in 3 dimensions, a pattern began to emerge. Every oscillation of ThreeI Atlast's pulse carried amplitude peaks, arranged in proportional symmetry like a message built from geometry rather than words. Researchers at the Max Planck Institute for Radio Astronomy reconstructed the signal and found that its amplitude envelope repeated every 247 seconds, identical to Atlas' established rhythm. Each repetition encoded 6 frequency shifts that corresponded to the spectral lines of hydrogen, helium, carbon, oxygen, nitrogen and iron, the 6 essential elements of organic chemistry. The implication was staggering. The message was chemical, not linguistic. It described matter itself. The team's analysis showed something else when the signal's waveform was converted into a spectrogram. It formed geometric images rather than static noise. At first, the scientists assumed the visualization was an artifact of signal processing. But when they reran the analysis with different calibration parameters, the same pattern appeared again, 6 perfect hexagons spiraling outward around a single luminous point. The structure was mathematically flawless, a golden ratio progression rendered in frequency space. Nothing in nature produces symmetry that precise by accident. Across agencies, internal discussions grew increasingly uneasy. If Atlast had transmitted using the hydrogen line as a base language, it meant the message had been tuned to the most universal constant in the cosmos, one that every advanced civilization capable of radio observation would recognize. Hydrogen was the alphabet of the universe. It was the common denominator of existence itself, and ThreeI Atlast had just written a sentence in it. NASA's Deep Space Network confirmed the same residual pattern, days later reporting that the echo persisted, faintly repeating in intervals far beyond the 12-second transmission window. The signal seemed to self-perpetuate, bouncing between the solar magnetic field lines like a trapped resonance still seeking a receiver. Engineers called it a self-sustaining whisper, a pulse that refused to die. The message remained encoded, waiting to be understood. When the waveform was finally rendered in high resolution, its true shape became clear. It wasn't random static or fractal noise, it was geometry. 6 perfect hexagons spiraling outward from a single radiant center, an elegant symmetry identical to the final images captured by the James Webb Space Telescope of the ThreeI Atlast complex itself. A mirror written in light drawn across the language of hydrogen. The transmission wasn't just a signal, it was a blueprint. When researchers reconstructed the waveform of ThreeI Atlast's 12-second transmission in full 3-dimensional space, the result was shocking. It mapped almost perfectly onto the orbital architecture of our own solar system. Each harmonic pulse corresponded to a planetary node, each phase shift to a gravitational resonance point. Atlast had not simply spoken in frequency, it had drawn in orbit. Mathematicians at the Jet Propulsion Laboratory and the European Southern Observatory cross-referenced the reconstructed lattice with real orbital data. The fit was unnerving. The 6 hexagonal spirals from the hydrogen-coded message aligned precisely with the relative positions of Mercury, through Saturn scaled logarithmically to reflect energy density rather than distance. In other words, Atlast's transmission wasn't random geometry, it was positional data. But more than that, it was predictive. When the temporal coordinates embedded in the wave were decoded, they didn't mark past or present, they marked future alignment. That date was June 9th, 2031, a time when Jupiter, Earth and Mars would form a rare harmonic conjunction unseen in more than 2 millennia. Astrophysicists called it the resonant arc. In Atlast's geometric model, that arc was the keystone, the anchor of the entire lattice. The moment the planets reached that alignment, Earth's magnetic poles would form part of the same nodal web that linked the Atlas complex across space. It was as though the signal had been anticipating a cosmic window, an instant when the solar system itself would complete the pattern. Global observatories began running synchronized scans in preparation for the date, using every instrument from ground-based radio telescopes to orbital radar. But something strange began to happen. Every attempt to ping the coordinates of ThreeI Atlast returned a subtle echo, not from its last known position beyond Jupiter's orbit, but from the direction of Earth. The delay time of the echo matched the distance to our own atmosphere. It was as if Atlast's reflection was coming from here. By late 2030, coordinated tests were run to confirm or dismiss this anomaly. When hundreds of communication towers, radar arrays, and astronomical stations transmitted in unison, they noticed a phenomenon none could explain: a faint feedback pulse synchronized across all frequencies. It wasn't interference, it was structured reflection. Every outgoing signal, no matter its origin, returned amplified by an identical phase pattern. The Earth itself seemed to be part of the resonance. Some believed ThreeI Atlast had somehow established a standing wave using the planet's electromagnetic shell, embedding its signature into the ionosphere like a mirror field. Others went further, arguing that Atlast had copied its own information into Earth's electromagnetic environment, creating a synchronized replica of its pattern within our skies. Satellite telemetry showed harmonic interference points, lining up exactly with the coordinates of major cities, as though each communication network had unknowingly become a node in the design. The planet was glowing invisibly to the rhythm of the object that had left it behind. Then came the final confirmation. During a routine broadband sweep conducted by the Square Kilometre Array, a surge appeared across the entire terrestrial spectrum, an echo of Atlast's pulse, repeating once every 247 seconds. Except this time, it didn't come from space. It originated from Earth. In that instant, the realization was unavoidable. ThreeI Atlast had never been merely transmitting to us. It had been synchronizing with us. On June 9, 2031, at a 4:47 UTC, the predicted alignment occurred. For 12 minutes, the background noise of Earth's magnetosphere dropped to near zero. Power grids across multiple continents recorded a subtle oscillation, a faint but measurable hum identical to the Atlast pulse. And for one brief blinding moment, telescopes around the world captured a flash reflecting back from the void beyond Jupiter's orbit. But when the light was analysed, it wasn't reflection. It was illumination, our own signals returning scattered from something vast and invisible, perfectly synchronised with the shape of the world itself. ThreeI Atlast hadn't simply brightened the solar system. It had been illuminating us back. And then silence. For 3 chapters, the story of ThreeI Atlast unfolded like the slow awakening of an idea hidden in the dark. It began with motion, a small, irregular body crossing the boundary of our solar system. But from its first recorded deviation, it refused to behave like anything known to science. Chapter 1 revealed the object's defiance of gravity, its unexpected course, corrections, its radiant bursts. The first tremor of awareness spreading through every observatory on Earth. It was the moment humanity looked up and realized that space long thought to be silent might be watching back. In Chapter 2, the anomaly deepened into confrontation. As the flare brightened and the data multiplied, institutions fell quiet. Communications stopped. The global networks that once celebrated discovery became corridors of silence. ThreeI Atlast no longer appeared to be a visitor. It was acting, reacting, calibrating. Each burst, each temperature shift, each echo through the ionosphere suggested purpose. When radar confirmed its capacity to self-correct and accelerate without propulsion, the line between observation and intelligence blurred. Science was no longer measuring an object, it was studying intent. Then came Chapter 3, the revelation. Atlast split into a binary system, 2 bodies moving as one mind. Their pulses synchronized, forming geometry and motion, not random, but structured, deliberate. The transmission that followed lasted only 12 seconds, yet within it lay a pattern, older than language hydrogen symmetry resonance, and the design of our own solar system encoded in light. For the first time, humanity was faced with a message written in the fundamental grammar of existence. And when the blueprint aligned with Earth's future orbital path, it became clear that Atlast was not simply traversing space, it was anticipating it. Across those 3 chapters, the narrative evolved from mystery to meaning. What began as a question of physics became a meditation on connection. ThreeI Atlast turned from a celestial anomaly into a mirror, one that reflected our own search for significance. Its pulses, its silence, its geometry were not answers but invitations. Invitations to look closer, to listen beyond the noise, to consider that perhaps intelligence in the cosmos does not announce itself with words but with resonance. When the final alignment came and Earth's magnetic field echoed the same rhythm once traced beyond Jupiter, the circle closed. The light returned to its source. The universe exhaled. And then there was silence again. Not emptiness, but balance. A quiet proof that something out there had recognized us, matched our frequency, and for one timeless moment synchronized with our existence. ThreeI Atlast had not merely passed through our system. It had left a pattern, a living equation waiting for us to understand. And perhaps that is how contact truly begins, not with a message received, but with a realization shared. There's a kind of stillness that follows revelation, not the silence of emptiness, but the quiet that comes after a truth too vast to process. When the data finally settled and ThreeI Atlast drifted once more into the deep dark between worlds, humanity was left staring at numbers that felt more like scripture than science. Every coordinate, every pulse, every echo carried symmetry that shouldn't exist in randomness, and yet it was there, written in wavelengths, not words. For months, scientists debated what they had seen. Some called it a machine, others a signal. But a few began to see it differently, not as a visitor from outside, but as a function of the universe itself. A pattern awakened by resonance, waiting for the right alignment, the right observers, the right moment. Perhaps Atlast was never meant to arrive. Perhaps it had always been here invisible until the world learned how to notice it. The aftermath was stranger than the event. Long after the twin lights of Atlast faded beyond Jupiter, a residual pulse remained in the background noise of every deep space receiver. It wasn't constant, it came in waves like breath. At intervals of 247 seconds, the hum returned subtle and rhythmic, threading through the ionosphere, as if Earth's atmosphere had memorized the frequency. No one could explain it, and no one could ignore it. Something had changed in the way we listened. Radio astronomers began detecting structured interference in signals that had always been pure static. The cosmic microwave background, that faint afterglow of the Big Bang, showed minute deviations that matched the Atlast pattern down to 6 decimal places. It was as if the echo had seeped into the universe itself, rewriting the silence. Outside the labs, a cultural shift began. Artists painted spirals and hexagons without knowing why. Musicians tuned their instruments to frequencies that aligned with Atlast's harmonic intervals. Children in schools learned about the event not as a mystery but as a milestone, the moment humanity's instruments caught a reflection of something larger than life, larger than intelligence, larger than imagination. In that quiet ripple of awareness, science and faith finally shared a language, the language of resonance. But beneath the wonder, unease lingered. The transmission had been precise, predictive, intentional, and then it had stopped. Why? What was left unfinished? And why had the final alignment pointed not beyond the solar system but directly toward Earth? To some, the idea was clear and terrifying. Atlast hadn't simply shown us a map, it had shown us instructions. Across observatories, teams began comparing old datasets. In the noise of the 1977 WOW signal in the radio burst from Proxima Centauri, in the unexplained alignments of pulsars, they found fragments that seemed to belong to the same structure. Different eras, different frequencies, one pattern. A whisper threaded through decades, connecting every moment we thought was random. Every anomaly, every question, every fleeting glance into the void might have been part of one continuous transmission, waiting for someone to assemble it. Perhaps ThreeI Atlast wasn't the beginning of the story at all. Perhaps it was the middle, the moment awareness became mutual, the point where observation became recognition. And somewhere far beyond the edge of the heliosphere, another object may already be moving one step ahead of the next. Alignment, one rhythm closer to whatever comes after the silence. As the final data stream fades to background hum, one truth remains unshakable: the universe is not still. It is pulsing, alive, responsive. And for the first time, humanity has felt the pulse move through the fabric of its own world. We have listened, we have echoed back. And in that exchange, brief mathematical luminous something ancient within the cosmos stirred and turned its gaze toward us. This is not the end. This is only the pause between transmissions, and somewhere out there, ThreeI Atlast is still waiting for the next alignment.